Welcome to this lesson on radicals. In this lesson, we'll learn how to add and subtract them. Before we begin, I want to be very upfront and tell you that you can only add and subtract radicals when you have the same radicand. So looking at the first problem, it would be possible to add these two radicals because they have the same radicand. Remember the radicand? It's the number that's underneath the square root symbol. So in this case, because they both have a 2, it would be able to work them out. For this example here, not so much because the radicand is a 5 and this radicand is a 75, but we'll handle that when we get to it. For now, let's just focus on this first example. And the question here is, well, how do you add the same radicand whenever you can? Because now we can. Very simple. Always look at the coefficients. Remember, the coefficient is the number that is attached to the radicand. So the coefficient here is 4. For this second one, although you don't see a coefficient, there's an understood 1. There's an invisible 1 there. And the reason why we want to know that is because in adding and subtracting, you focus on the coefficients. So this is 4 plus 1, which is going to be a 5. Now, this is important. Do not add the radicands. Do not add the radicands. You would leave this as 5 root 2. For question number 2, which is right over here, we already know that we cannot add these in their current state because they don't have the same radicand. So our goal is to simplify them whenever we can or wherever we can, and hopefully when we simplify, we'll end up with the same radicand, which then will allow us to subtract these. So 5 is already, the radicand 5 is already in its lowest terms. That means we need to turn our attention to this radical here. So let's just pull the square root of 75 off to the side and try to simplify it using the knowledge we picked up from the last lesson. So when we're trying to simplify square root of 75, we are asking ourselves, what two numbers do we multiply to equal 75? But remember, we don't want just any two random numbers. One of them has to be a perfect square. And again, don't start with 1. So we'll start at 2, but 2 doesn't go into 75, so we'll go to the next digit, which is 3. 3 times 25 is actually 75. And guess what? This will work because one of those terms has to be a perfect square and 25 happens to be one. So now we can rewrite this as 3 times 25. And because 25 has a square root of 5, it goes on the outside. So it's going to be 5 root 3. Now, remember, however, that this term had a negative 2 in front of it. So this 5 that went out really has to multiply this negative 2 that was originally on the problem. So I'm going to rewrite this as negative 3 root 5 because nothing changes on the first one. However, the second one is negative 2 times 5, which is negative 10 root 3. And then now I can clear this extra work that we did, scratch work, off to the side. And now we re-examine this and see, hey, do we now have the same radicand? Unfortunately, we don't. So because we don't, we would leave this answer as it is. And now for the third and final question on this page, we will try to add these radicals. We have 3 terms this time, right? But remember, we can only add or subtract if we have the same radicand. Right now, this is a 5, a 96, and a 24. We can't. However, we can simplify this one. And we can simplify this one. So let's work on that one at a time. What two numbers do we multiply to get a 96? Remember, we don't want any two random numbers. One of them has to be a perfect square. So let's take the root 96 off to the side and figure this out. 2 times 48, but neither the 2 nor the 48 is a perfect square. So that's not a good pair. What about 3? 3 goes in here, 3 times 32, but neither the 3 nor the 32 is a perfect square. What about 4? 4 goes in here 24 times. So this might be a good pair because 4 is a perfect square, but it's not the best pair because 24 also has a 4 in it. So that's not a good pair to go with. Let's keep going. 5 doesn't go into 96. However, 6 does. And that will be 6 times 16, which is the best pair to go with. Reason being, 16 is a perfect square and 6 does not have a perfect square in it. So we're going to break down the square root of 96 into 6 times 16. The square root of 16 is 4, so the 4 goes on the outside, leaving us with a root 6 on the inside. Now remember, there was a 2 on the outside that has to be multiplied to it. So we'll end up with an 8 root 6 on the outside. So 8 root 6. And we still have the 5 root 5 on the outside. Now we can focus on this part right here. So square root of 24, we can simplify it to 4 times 6. And that's our best pair. So square root of 4 goes on the outside as a 2. And we are left with a 6 inside. Remember, this 2 is going to have to multiply this negative 20, which makes it a negative 40. So this is minus 40 root 6. And now once we've simplified the terms, we look again to see if we have any like terms. Like terms would be the ones that have the same radicand, and you find that those both have a radicand of 6, meaning we can simplify them. So I'm going to copy down the odd one out, 5 root 5, because nothing changes. But then here we would have 8 minus 40, which is negative 32 root 6. And because these have different radicands, there's nothing we can do about them. So we have to leave this as our final answer. So in summary, you can only add or subtract radicals if and only if they have the same radicand. And then when you're adding them, only add the coefficients, only the whole numbers that are on the outside of the root, like the 4 and the 1 for question 1. And for question 3, we had 8 and negative 40, leaving the radicands intact. Don't touch the radicands. In the case of question 2, we had different radicands, so there's nothing we could do. We just left the question simplified as our final answer. And that concludes this lesson on radical addition and subtraction.